this talk, I may challenge a few assumptions you may have about UIs, Compose, and Android architecture. And I don't really say anything about architecture in the topic of the talk, but you may be here wondering, was it all architecture? And the answer is, it kind of always has been, right? Okay, but about who I am, hello, I am TJ. I'm a software engineer at the Client Media Foundation team at Airbnb. You may have seen me on YouTube talking about the architecture and UI layer on the Android developers YouTube channel. You might have read these documents on developer.android.com, UI state production, I help write those. Or you might have used any of these samples on GitHub. I helped build them as well, along with these other fantastic people. Okay, but before we go any further, I'd like to do a brief Android architecture recap. In the architecture guide, you say that your Android app is composed of a data layer, which has data sources and repositories that sit on top of them. And then you have the UI layer, and that's composed of UI elements and stakeholders. So far, I haven't said anything too controversial, at least not yet. But if you things get really interesting when you start looking at this chart from the perspective of the consumer. So if you flip it, and you put the data layer on top, and you have the UI layer as a consumer, the docs, you start seeing things like business logic, screen UI state, UI logic, UI element state. And, the general theme that comes up is this abstraction really necessary? Some people are a bit more vocal. I'm particularly fond of a particular name that I see on Twitter a lot. It goes, all these architecture astronauts. And then they kind of get a little upset because, why are you complicating things? Things don't need to be that difficult. To which I say, you know what? I get it. But I would really like to explain here what really differs in the different logic types. So let's talk about update propagation, or how you get notified that something has changed. Well, there's two ways you can really do this. There's reactive push and a notify and pull. And when I say reactive push, I'm talking about things like RxJava. You've probably used this often, or you've used Kotlin flows. The thing to note here is you kind of have this, subscriber model where you subscribe to a stream and then you get updates. But by subscribing to this stream, you implicitly have this concept of back pressure. Now, if you do notify and pull, this is a thing, APIs like listenable future and compose snapshot, but there is no implicit back pressure. If you use a listenable future and do listenable future.get and you have a listener, or in terms of compose, when you get recompose, there's no back pressure. You just get the callback when you get the callback. Another way these things change is in state management. Now, this is where you start talking about things like immutability versus mutability. And then it's also worth asking, why did immutable state become so popular? Why did it take off? Now, if your answer is kind of in terms of concurrency, where you talk about it's really difficult to manage manage state, mutable state in concurrent environments, well, that is true, but it does come at the cost of garbage collection pressure because you're allocating a lot of objects. Now, opting to use immutable state is another point to ask ourselves a question. Is this really an API restriction? And when I say an API restriction, what I mean is, think about going from callbacks to coroutines. Before, you'd have to register a callback for any asynchronous code. Think async task. With coroutines, we can now write sequential procedural code, even though it's not, you suspend, and it looks really simple. So when it comes to dealing with mutable state in concurrent environments, are there any APIs that would actually let us do this? In this context, I'm going to again mention that compose state snapshots are actually isolated, and they do this using thread locals. If you want to learn more about how this works, I would really recommend you listen to Zach Klippenstein's talk on the Introduction to Compose Snapshot System, where he does a deep dive into all of this. But ultimately, what I'm trying to say is your app, you start in the data layer, UI layer, and I think, and this is an anecdote, but if you're working with a data layer, it's better to kind of restrict the use of reactive push APIs to your data layer and embrace immutability in your data layer. So you're listening from something from your database, something changes, you get an update, kind of restricted there. But in your UI layer, you should use the notify and pull API, specifically compose snapshot state, and embrace mutability. Not saying that these APIs can't work in the data layer, it's just that, for almost any database library you have, it's going to give you a flow. Everything is already, there's a lot of inertia there. But in the UI layer with Compose, you're not restricted. So what this means is, say you have your app data, and you want to bring it into your UI layer, you want to show things, you kind of like apply business logic to it here, after which you get your UI state, and you apply UI logic to it, and then that gives you your UI element state. Now this is better illustrated with an example. Here I have 3 images, and you may notice that the top 2 are doing something, and the middle one is not really, the first and the last are doing something, and the middle one isn't really doing anything. On the top I'm using Coil, in the middle I'm using Glide, and in the third I'm using a manual painter. Now if you look at the bottom, you may notice that I'm actually changing the content scale for each of the images. But I'm not just changing it like snap into it. I'm actually interpolating it so it changes dynamically. But you may wonder, why isn't Glide working? Well, if you look at the source code for Glide's Compose integration, they actually did not use mutable snapshot state. And so the change in the content scale cannot be seen. But why can't that change? Why can't it be seen? Let's talk about that animation real quick. Now, if you look at Compose source, if you look at the content scale, it's a really simple interface, and it has one abstract method to compute the scale factor. The scale factor is a value class, meaning when you create one, you don't necessarily allocate an object. It's just a wrapper around a primitive long. And it has 2 components, a scale X and a scale Y. So if I'm trying to animate the content scale, this is really what I'm trying to animate. If I was going to animate this with something like a flow, for every emission I wanted to push something out with the flow, or even RxJava, you'd kind of get something like this, where every, second or how often you want to push stuff out, you'd actually push updates like this. But because it's a flow, and a flow is generic, whenever you're pushing something out, you implicitly will be boxing the primitive, and you'll be actually allocating an object. Now think about the frame rate of your device. Most devices run about 60 frames per second. Do you really want to allocate an object that frequently? 5 years ago, I was at Game Changer and I built the game stream experience. And what's actually going on here is I have a single image view and I have a very wide image. And to kind of change and kind of like shift the image as if it's playing a video, I'm actually just using an image view with a scale type matrix. And I have a flow that is creating a new matrix and is dynamically updating this. It worked, but the GC churn was horrible. Let's see how we can do this in Compose with notify and pull and mutability. So let's see how we'd actually try to create this with Compose. So imagine you have a composable function that has content scale.interpolate. I give it some animation spec, in this case a spring. The first thing I want to do is I want to remember an interpolation value. I'm going to start at 1 because at this point I've successfully gotten to my destination. I want to remember my previous content scale. In this case, it is my current content scale. And then I also want to have the current scale, which is exactly what I do have. It's almost exactly the same. The only difference is that every time this function is recomposed, I want to look at the value. If the value is different from the last time it was called, I want to set the previous scale to my current value. If not, if the interpolation had not completed, I kind of want to capture what I already have. And then after that, I want to set my interpolation to 0. When I set my interpolation to 0, I kind of want to start a new animation. So to start the new animation, I do a launched effect, and I use the Compose Animate APIs, and I animate from 0 to 1. Every time the animation runs, I update the interpolation. After that, note here I am remembering and I'm creating an anonymous content scale object. Notice that I'm using a remember, and then I compute the scale factor, and the scale factor is just a function of the start and the stop. After I get the start and the stop, I then use the linear interpolation function, or lerp, to create a content scale. The thing I want to underscore here is I only create this content scale object once. There is no object allocation in this pipeline. And with that, this is what UI logic in Compose is all about. Because Compose runs at the frame rates of the Compose monotonic framework in the coroutine scope in Compose, this will run perfectly in sync with the frame rate of the device. This is what I was talking about with reactive push. if you were trying to run it on a Samsung Galaxy that had a 120 refresh rate, how do you know that if you're using reactive push without trying to figure out what device you're on? But Compose Runtime does all of this for you. This is what UI logic is. So let's talk about building an simple image component with this. So I talked about how, so your image component has some photo arguments in it. So I could have a URL, a content scale, which is what we're talking about, an alignment, and then also a content description. So the photo composable for displaying this may just have the photo arguments as an argument, the modifier, and then here I'm just going to delegate directly to the async image from coil. I give it my modifier, I give it the model arguments, I give it the content description. But importantly, when I'm giving it the content scale, I can just give it content scale and then call that composable function from before, interpolate. When I do that, another thing I want to highlight here is you may notice that my photo composable just takes 2 arguments, and you may wonder, why did you bundle all the arguments into one? Why didn't you pass everything piecemeal? It's a very good reason for that. I'm going to come back to that, I promise. But with that, I get this, composable image where as I tap it, I can scale with no object allocation, and it looks nice. But you might be thinking, TJ, this is a bit of an academic example. Why are you even interpolating a content scale in the first place? What use is this? To which I say, I would like to introduce to you some really, really, really cool architecture and media components. We're going to see some cool stuff, and I mean really, really cool. All of this is kind of something I've been working on for a bit called navigation as state. Now, I don't know if you've listened to any Frank Sinatra, but he has a song called Fly Me to the Moon. I mentioned before that there are a bunch of people that say all these things, call it architecture astronauts. Look, in Fly Me to the Moon, Sinatra says, when I get you up there, where the air is rarefied. Where we're going, the air isn't so much rarefied as much as it's rare. We're going into space. We're doing some really, really cool stuff. Okay, but navigation as state this is what I was working on at Google. You have a basic list detail flow. No animations yet. And my job was to write guidance on how to help developers adapt this from a phone to this. How do you make list detail flow look amazing on tablets or large screen devices? So improve the list detail flow ergonomics was my job. The more I wrote it, the more I was like, man, this is kind of annoying. I just kind of want to grab what I'm already saying, stick it on the left, and put the detail screen on the right. I kind of wanted a single dynamic navigation host. And I kind of wanted to treat navigation as business logic. Just because my screen had gotten bigger didn't mean I had to rethink what my navigation was. And Trio, at droidcon last year, there was a talk from Airbnb about Trio Compose architecture with Mavericks. You should check that talk out if you haven't already. But what I want to say is, imagine you're building an app and you have a listing screen. You tap a button, you go to the detail screen. You tap another button, you're on the gallery screen. And pretty soon you have a basic app backstack. But then most apps today, we have a bottom nav, and on the bottom, or if it's a tablet, you have a nav rail. So really your navigation kind of looks like this. It's this cloud. All this is what I would call my navigation state. Okay. Now, outside of that navigation state, if you're dealing with a phone, a tablet, or what have you, you have this window size class. You could have predictive back. That's a new thing. The density of the device could change, or you could have user preferences. But you could have all these things that change that really, even though it changes your presentation, it really doesn't change your navigation state. So I'm thinking, and this is where the astronaut stuff comes in, should there be something called an adaptive navigation state? Bear with me and let's see what we can do if we do this. And then you may notice the color separation here. So I'm trying to treat navigation as business logic and all this adaptive stuff as UI logic, because that's what happens when the phone is folding. Okay, so what is adaptive navigation state? What am I really trying to do? Well, think panes. And when I say panes, I'm meaning things like the primary pane, the secondary pane, the tertiary pane. You could have bottom sheets. And then you're like, if you're still having pain, trying to figure out what I mean by panes, What I mean by paint is this. This is the YouTube app. So on this YouTube app, on this screen, you can see the primary content is what's on the left, the secondary content behind it, and in the comments, you have bottom sheets. So these are what these panes are. They're just descript parts of your app. So to learn more about panes and stuff, I'll recommend from Google I/O this year, there's a talk about building adaptive Android apps. Okay, now that we have navigation state and we know what panes are, what we're really trying to do is, given our app, we kind of want to create mapping functions that go from one navigation state, and depending on what configuration is in the UI, to all these things. So, again, business logic, UI logic separated. Okay, so when you go to a detail screen, same thing. But then, what if when it's expanded, you don't change your navigation state, but your navigation state had pointers to say, hey, if the screen is expanded, I want the detail to go to primary and the listings to go into the secondary. Well, the thing is, I was actually able to do this. And I don't have any animations running yet, but I want to underscore what's actually going on here. On this large tablet device, I have my listing screen, but when I go into the detail screen, I literally yank the listing screen, shove it to the left, and put the detail screen on the right. I'm yanking the entire thing with its view model. If I had scrolled, everything is preserved. And the way I'm doing this is I'm using movable content of. But the thing with the light bulb and where things start to get really cool is, what if I repeat this on a smaller scale? Is there anything like a movable shared element off? If I can move a screen, its view model, all its state, just like that, what happens if I apply this to shared elements? Well, let's talk about what movable content of is. Movable content of is you literally hold a composition as a value. In the same way you can hold a reference to a string, you can hold a reference to an integer, you can hold reference to a composable, a node in the UI tree. You have a reference to it, and you can yank it out and place it anywhere you want. So in this case, I'm trying to create a movable shared element of. I have a key, and I have some shared elements, which if the shared element does not exist yet, it's kind of like a factory function. I want to create it. So here I'm going to have some UI logic for whether I want to share this object, if I want to show a blank space, or do anything. So if I look at that adaptive navigation state I was telling you about, I can figure out what pane I'm currently in, and then I can check if that pane is animating in or animating out, and then I can write rules that say I should not use this shared element if this is animating in or out. With that, if it's currently animating, if it's not currently animating in, I can return an empty box. Otherwise, I can actually create or update my shared element object. If you go into the source for this, what I have here is I have a modifier, the movable shared element. And if you go through it, you'll notice I'm using the shared element primitive. This is what all the shared element APIs and compose are built on. It's called the approach modifier node. To learn more, I would really recommend you check out this video on YouTube from Doris and Rebecca on the Compose Toolkit team, on the Developer Relations Toolkit team, where they talk about advanced layout animations in Compose. I have teased that we're doing, I'm going to show you some really cool stuff, so let's cut to the chase. But also, I do want to highlight that this signature has that modifier and a generic object T. You may have noticed for the photo argument, I was saying, why am I bundling everything together? This is why. Again, this is UI logic. So in my case, I'm moving from the feed screen to the detail screen. So in my feed screen, I have a horizontal pager. I have some media that I want to display. I have the thumbnail using movable shared element off. And remember, that returns a composition value. I have a composition as a value. I'm not emitting any UI yet. When I invoke it, I actually then call it. But I want to show you that here, I am invoking it with content scale.crop. If I go to the next screen, it has literally everything the same, but this time I'm invoking it with content scale.fit. Can you see where I'm going with this? I am going to create a shared element transition where not only am I animating the position and the size, I am animating the content scale. So there's no discontinuity. I'm going from a square to a rectangle, and when I pull it down to dismiss it, because I have that UI logic that says, hey, you're going to nothing yet. You haven't completely dismissed this yet. When I let go, it animates neatly into position. But it gets cooler. Because remember I said the very first thing I was trying to do is I was trying to make this work on large screens where I had a tablet and I was already using movable content off to move the feed screen to the left. What happens when you have a movable content within another movable content? You get really cool animations like this, where as I pull it out, the shared element kind of moves from the left to the right, and everything just looks beautiful. And again, I want to stress, the default shared element transition APIs in Compose, even though it's a shared element, the two composables on two different screens are completely different composables. What happens is, as the new screen is coming in, it places the new one where the old one used to be, and it animates it there. What I'm doing here is I am doing a literal shared element. The same UI element that was on the old screen, I am literally using movable content to move it to the new screen. I am moving a composable between navigation destinations. If your app is modularized and there are different modules, it doesn't matter. I am literally moving it from one screen to another. This is cool. In case you're wondering what was going on the animation on the right, where I had a lot of things going on, this is what's going on architecturally. Remember, I said because I'm doing things, I am not changing my navigation state. So on my gallery screen, I'm showing, even though I have an expanded screen, I'm showing the primary screen. The minute I trigger predictive back, interesting things happen. I move whatever was on the gallery screen, I put it on the transient screen because I'm about to dismiss it. I look into my navigation hierarchy. Again, I have not actually my navigation state has not changed. And then I put the detail in the primary, the listings in the secondary, and everything just looks fine. And then the minute I complete the predictive back, that is when I actually change my navigation state. So being able to change your adaptive navigation state without actually changing your core navigation state is the reason I'm able to go do cool things like this. But it gets better, right? I told you we're doing cool things, like we're doing some really ridiculous astronaut stuff. What happens when we do this for video? What happens if you make a movable video shared element transition? Well, let's talk about how that content scale animation works. In Compose, they give you an image composable, and the image composable, you give it a content scale. Behind the scenes, that content scale is actually going to create a matrix and use that to scale the image appropriate for the matrix. There is no video composable. So unfortunately, that means we're going to have to do a lot of matrix math ourselves. So what does it mean to scale and apply a matrix to a video? So for this, I'm going to be using a texture view. And by default, the texture view in Android, you put any video in it, it will just stretch it to fit the image. It fits it to the bounds. This is how simple matrix manipulation is in Compose. So I already have a field bounds applied to the texture view. I want to get rid of it. So I'm going to create a field bounds content scale, create the scale factor, apply the scale X, the scale Y. But at this point, I now have a double field bounds. But I can just call matrix.invert to invert it, and this kind of removes the content scale. Next, I want to apply the content scale I want. So you get the desired scale factor, you compute the scale factor, I apply my scale X, my scale Y. But at this point, all I've done is, zoom in on the image. Now I want to punch into the center. So I need to do some matrix translation. So to do that, I need to apply my alignment, and then I take the scale size, apply it to my scale factor, apply the alignment offset, and then finally translate X, translate Y. And with this, we can actually try to apply this to video. Let's see how it looks. I was ahead of myself. But this is what it looks like with video. I have kind of like this grid, and I can tap it. And notice the video does not stop playing. If you've used any app in Android where you're going from a list to detail, you may notice there's been a brief pause because the EXO player needs to be detached from the current screen and reattached to the new screen. With a movable shared element transition for video, there is no pause. You are literally moving the Android surface from one screen to another. No rebuffering, no audio breaks. This is how good Compose is. Of course, I've been talking about large screens a lot. So here it is again on a larger screen. I can do a shared element transition with video. I can drag it, pull it aside. It keeps playing, no breaks, no stops. And now you may be wondering, like, hey, there's no official support for Exoplayer and Compose yet. But again, Compose is so good, it makes it kind of, and we've done already so much custom stuff, custom video player, custom shared element transition, what's one more custom thing, right? So what we can do here is, again, notice that I just have the state and a modifier. So again, if I can show video, I want to play video. And then the way that works is I have my Exoplayer. I remember my updated Exoplayer instance. I check the surface size. I take my video matrix. And then I use the Android embedded external surface composable. This is just a wrapper around the texture view. With this, I can apply the first modifier, and then here I use a fixed surface size because my images are small, so this is just, my videos are relatively small, so this is an optimization. And then I give it the video matrix transformation vector. And then with that, I do my surface callbacks. On surface, I have my created surface. And then when the surface is destroyed, I of course yank out the player. And then I take a snapshot flow, and every time I have an updated player, I just set it to my video surface. And that is how easy it is to, integrate Exoplayer and Compose without, any official support. And then finally, I do a launched effect. I create anytime the video size changes or the surface size changes, I create a new matrix, and then that's how I apply it. This is not as pretty as the image one, because if you go into the matrix source code in Compose, it says this class needs some optimization because every time you change the matrix, you actually allocate in a new float array. So it's not as efficient as even they would like, but I'm sure that would change soon. Now, it's easy for me to do all this from the safety of my screen and pre-recorded video. So I figured I would like to actually show you this in real time. So here's my Android Studio. And I am going to go to the explore page where I have my videos. And again, this is just a video feed. Everything here is in Compose. As I scroll, the video that I have highlighted is going to start playing. Here, there's a bird. And I'm going to grab it. And then notice that the audio did not stop. I can go here with predictive back. This is not predictive back. This is my own custom drag to dismiss. But notice the video is still playing. I'm going to leave it. It's going to animate neatly back into place, right? And then I could do it. I'm see if I can try to get the predictive back working. I'll deal with something else. There we go. That's predictive back. And the video is still playing. The audio is still playing. And this is only being empowered because of the navigation structure I have. And then let's go back to the listings. I forgot to stop the video. That's why. If I go back to the listings here, I'm going to go here. And this is my, pretty much the animations work regardless of where I am. And again, I am moving this same component. This image component has followed me from the home screen, and it's literally staying with me as I kind of pull it and drag it about. So let me stop this. So this is where I'm going to get on my soapbox a little bit. I've made a lot of jokes about being an architecture astronaut. We're here at a developer conference, right? And, a healthy dose of skepticism isn't necessarily a bad thing. But with Compose, there are a lot of people that enjoy being cynics. And I don't think cynicism necessarily helps. From things like architecture astronauts are saying everything that we can do, or Android is changing too much and stuff. It's helpful if you kind of look at these things as a progression. First, we had Kotlin, we've had coroutines, we've had Compose. And there's some, I don't know if it's fate or anything, but there's some alliteration here, but because Kotlin, Compose, and all these things just kind of accompany each other. All these things that have been kind of like a progression. In the last talk that was in this room, Mohit was talking about the Compose compiler and the way it works. And it was saying how when you recompose, you don't necessarily have to invoke the function yourself. Everything I've done with movable content if it kind of reminds you about the promise of what fragments are, it's literally the same thing, but except with fragments or with a text view you had to call set text yourself. Fragments, you had to commit the fragment transactions yourself. Here with Compose, everything I'm doing movable content it was all those methods kind of set a transaction. It's still happening, but the Compose compiler is doing it for you behind the scenes. So what I'm trying to say is, just like how, coroutines does change how we think about asynchronous stuff, Compose lets us think about UIs in a different way and do things that I can't even. So my experience in Compose was, first, I thought Compose was good. And then I got to the comparatives point where I was like, Compose is better than Views. But now I'm at the superlative where I'm like, Compose is the best UI toolkit I've ever worked with. Because again, the shared element is not a smoke and mirrors thing. It is a quite literal shared element transition. And I think that's cool. So I would like to invite you all to, I should put this back on. It's kind of fun up here being an Android architecture astronaut. And in some way, that kind of gives us like a AAA rating, right? Android architecture astronaut. So it's good over here. If you'd like to play with the app I just demoed, it's over there on my GitHub. But yeah, come up here, be an Android architecture astronaut. It's fun. You can do cool things. And yeah, any questions?